Hi everyone, and welcome to this podcast on the curves IS and LM. To better understand the curves IS and LM, let's review some basics of math geometry. Let's take a simple affine equation, such as y equals x plus g, with g being an exogenous variable. Say g equals 1, so we have y equals x plus 1. We represent it in the plane xy by a straight line that crosses the y-axis at 1. If one of the two endogenous variables, x or y, varies, then we will move along the curve. For example, say that we are at point A, coordinates 1, 2. From there, if x increases by 1, y will then be equal to 3, and we go to point B. We are still on the curve. If an exogenous variable, which is not expressed on the axis, varies, for instance, if g varies, the curve will shift. For example, if g increases from 1 to 2, the equation becomes y equals x plus 2. Then the curve shifts upwards. Be careful. If the coefficient of the curve varies, the curve will pivot, meaning that it is the slope of the curve that will change. If the equation becomes y equals 2x plus 1, for instance, the slope changes and the curve pivots to become steeper. To sum up, when an endogenous variable expressed in the axis varies, we move along the curve. If an exogenous variable not expressed in the axis varies, the curve shifts. And finally, the curve pivots if the coefficient or slope varies. Let's now focus on the IS curve. IS represents the equilibrium on the goods market. It is represented by a downward sloping straight line in the plane YR. This means that to maintain the equilibrium on the goods market, when Y or R varies, the other variable must vary in the opposite direction. So how can we justify this decreasing relationship? Well, first, mathematically, we can calculate the coefficient of the curve. In the plane YR, the coefficient is the variation of the interest rate dr when the revenue y varies. We obtain this coefficient simply by differentiating is with respect to r and y. We find the coefficient 1 minus c prime over I prime r, and we know that 1 minus c prime is the marginal propensity to save, which is positive. And we know also that I prime r is the sensitivity of the investment to the interest rate, which is negative. Now, economically, let's imagine that you are on the curve and for some reason the income y increases and we end up at point A. At this point, because y increased, savings increased. If we want to come back to the equilibrium between investment and savings, well, because savings increased, we need investment to increase. For investment to increase, the interest rate must decrease. We can do the same reasoning, but instead of starting with an increase in y, we can start with an increase in R, the interest rate. So we're now at point B. If R increases, investment decreases. So to come back to the equilibrium, if investment decreased, we need savings to also decrease to have the equilibrium between investment and savings. For this to happen, the income must decrease. So what does it mean when IS is more or less steep? Let's take two examples. First, IS1, which is not too steep. Say that the income increases and we go from the equilibrium to point A. To come back to the equilibrium, we need investment to increase, which requires that the interest rate decreases from R0 to R1. In this economy, the decrease in the interest rate that is required to come back to the equilibrium is relatively low. We say that the investment is, in this case, sensitive to the interest rate. Let's now take a different example, an economy where IS is steeper, which is the case for IS2. Starting from the same initial equilibrium, we also go to point A. This time, to come back to the equilibrium, we need a much bigger decrease in the interest rate from R0 to R2 to allow for the necessary increase in investment. So overall, the larger the slope of IS, in other words, the steeper IS is, the less sensitive the investment is to the interest rate. Another way to say the same thing, the more IS is flat, the more sensitive the investment is to the interest rate. The IS curve can pivot in the plane. For example, if households are pessimistic about their future and start saving a more important share of their income, in other words, if their marginal propensity to save increases, the coefficient of IS would increase and the curve would pivot to the right to become steeper. Another example, if business owners decided to be less sensitive to the interest rate to make their investment decisions, in other words, if the sensitivity of investment to the interest rate decreases, here again, the coefficient of IS would increase and the curve would pivot to the right to become steeper. It's very important to distinguish the effect of a variation of the coefficient, the curve pivots, and the variation of an exogenous variable that is not expressed in the axis. When an autonomous component of the demand, for example G, C0, or I0 is modified, for instance, if there is a negative demand shock that forces households to reduce their incompressible consumption, IS will shift to the left. If, on the other hand, we have a rise in public spending, which results in an increase in the demand, IS will shift to the right. Let's now take a look at the LM curve, which represents the equilibrium on the money market. LM is an upward sloping curve. To maintain the equilibrium between the demand for money and the supply of money, when Y or R varies, we need the other variable to vary in the same way. So how can we justify this increasing relationship? First, mathematically. Here again, we can calculate the coefficient of the curve. We obtain this coefficient by differentiating Lm with respect to r and y. We find that the coefficient depends on two things. First, L prime y, which is positive, because the demand for money increases with y. Indeed, when income increases, the demand for money for transaction purposes increases. Second, it depends on L prime r, which is negative, because when the interest rate increases, the demand for money for speculative motives decreases. Indeed, when the interest rate increases, households have an incentive to hold bonds rather than money, which gives no interest. Now, economically, let's imagine that you are on the curve and for some reason the income y increases and we end up at point A. At this point, because y increased, the money demand for transaction motives increases. The supply of money is, on the other hand, exogenous. Therefore, to maintain the equilibrium on the money market, the money demand for speculative motives must decrease. To do that, the interest rate must increase. Hence, when y increases, we need r to increase to keep demand equals supply on the money market. We can do the same reasoning, but instead of starting with an increase in y, we can start with an increase in r, the interest rate. So we're now at point B. If r increases, the money demand for speculative motives decreases. To come back to the equilibrium, we need the money demand for transaction motives to increase. And to do that, the income must increase. Hence, the slope of Lm depends on the sensitivity of the money demand to the income and on the sensitivity of the money demand to the interest rate. Usually, we make the assumption that the sensitivity of the money demand to the income is relatively stable over time. In general, households desire a quantity of money that is proportional to their income. This quantity will depend on the speed at which the money circulates in the economy. The higher the speed, the lower the quantity of money households will need for their transactions. This speed is, in general, relatively stable and constant over time and depends on institutional factors. Therefore, our analysis will rather focus on L prime r. Again, L prime r is the sensitivity of the money demand to the interest rate. It describes the behavior associated to the demand for speculative motives, which is decreasing with the interest rate because, as we said before, when the interest rate increases, the demand for speculative motives decreases. So what does it mean when Lm is more or less steep? When the slope is steep, it means that the sensitivity of the money demand to the interest rate is relatively low. Let's look first at Lm1. Suppose that we start from a point of equilibrium, and then the income y increases, which brings us to point A. This increase will result in an increase in the money demand for transaction motives. To maintain the equilibrium, we need the money demand for speculative motive to decrease, hence an increase in the interest rate. LM1 is steep, so in this case, we need a strong increase in R to decrease the speculative demand for money. Therefore, here, the demand for money is not very sensitive to the interest rate. Let's now look at LM2. The curve is less steep. The decrease in speculative demand is obtained through a much smaller variation of R. R will increase, but less than in the first case. Because in this case, the demand for money is more sensitive to the interest rate. So a small increase in R is enough to decrease the speculative demand for money. LM can pivot in the plane YR, notably if L prime R varies. If the sensitivity of the demand for money to the interest rate decreases, then LM will become more vertical. One common way to represent LM is to use different slopes depending on the values of the interest rate. For high interest rates, the sensitivity of the demand for money is low, close to zero. Indeed, when interest rates are high, the demand for speculative motives is very low because bonds provide a much higher remuneration. In this context, a new increase in R would result in a small decrease in speculative demand. On the other hand, for small values of R, the elasticity of the demand for money with respect to the interest rate tends to minus infinity. Indeed, when the interest rate is low, the opportunity cost of money is low, and households have a strong preference for liquidity. In this context, a new increase in R would result in a large decrease in the demand for money. In between, we have the usual upward sloping LM curve. Same as IS, the LM curve can shift in the plane YR when an exogenous variable, non-expressed in the axis, varies. This is the case, for example, when the supply of money, which is exogenous, varies. An increase in money supply will make LM shift to the right, and a decrease in money supply will make LM shift to the left.